Okay. Yeah, so today's lesson, I'll be teaching you on the next topic. Have you all started on the next chapter? Chapter 3? Started already now? On the elements? Not yet. Oh, okay. Evan, you started. Can? No problem. So I will just be covering the first part on elements. So if you can see the slides that I have, make sure you have your textbook with you, periodic table. Do you all need to get some water or anything? Just let me know. Because we are a very small group here, it's okay. All right. So you can also unmute to talk as well. Right. Jared, you finish your dinner? Or you're still eating halfway?
I'm eating halfway.
Good, continue. I'll be teaching, you just listen in, okay? Yeah. So no problem. I allow students to eat because I know, especially y'all are in secondary school, okay? Sometimes the timing can be very weird. Like maybe you have learning journey, you come back, it can be 6+, close to 7. Then when you reach home, you need to shower, get your dinner, etc. You need time. Yeah, definitely need time. Sometimes CCA also end very late. So no worries. Okay, this is the chapter that I'm going through. We are only going to cover the part on elements and something on the periodic table. Okay, so take it slow. It's not a difficult topic. In fact, you can see it as something interesting lah, because whatever you learn here, I have covered a little bit the last time when we refer to the periodic table a few times, right? Yeah, we did that. So what is it about this topic that is important? This will eventually lead us to look into the separation technique, okay, when we study the mixtures and how to separate them. So before we can go into that, you need to understand what is the most basic thing on earth, okay? So when we look at these particular slide, you will see sodium metal, you see sugar, you see chlorine gas, then table salt, there's brass, then copper wire, seawater. All of them are made up of different things. Okay, so what are the different things there? And then they also ask this question, right? So many substances in the world, how to classify them? So of course, there are ways to classify them. Okay, firstly, you need to understand what is the meaning of pure substance and impure substance. Okay, pure substance will have fixed melting boiling point. So if I were to, let's say, maybe refer to water, I think water is something that you are familiar with. What do you think is the boiling point for water? Can you all recall? Boiling point for water. Try. Okay. Have you all boiled water before in primary school? Then you try to measure the temperature, right? What do you have when, yeah, good. Yes, thank you, Jared and Evan. So boiling point of water is 100 and you put in the units, that's very good. Okay, degree Celsius. Remember we talked about the SI unit for temperature is actually in kelvins, but in Singapore, we are very familiar with degree Celsius and we use it most often. Now, melting point of water is definitely going to be different. It cannot be 100 degrees, right? If you understand the difference between or the similarity between melting and freezing, okay, it's just a conversion of the state, all right, in opposite direction. Okay, freezing is liquid to solid. So when we put water into the freezer, it is going to freeze into ice cubes, right? So after that, the ice cube can also melt to form water. So the melting and the freezing point is actually the same temperature. And what is that temperature? Do you recall? Let's try, see whether you all know. Okay, what is the freezing point of water? At what temperature will water freeze to form ice? Yeah, correct, Heidi. Yes, very good, Jared. Correct. It's actually 0 degrees Celsius. Okay, something that is very common in our daily life. You all must know. Okay, Evan, you also got it right. Okay, so now when we talk about pure substances, right, you have to understand and remember one important criteria. Definitely, they will have fixed melting and boiling point. So if I talk about water, melting point must be 0 degrees, and then boiling point must be 100. Anything that is not, 0 or 100 respectively, it is not a pure substance. That means it's not pure water. For example, if I tell you, okay, this colorless liquid here, okay, maybe this water bottle, my son's one, a very big one. Okay, this water bottle, the water inside here. Okay, I test the boiling point. It's 101. Can I say that this is pure water? I give it to Jared. I say, Jared, drink this. This is pure water. But it's 101 degree boiling point. Do you think it's pure water? No, cannot drink. So that is also one way scientists or people who are doing some food tests, right, identify whether something is pure. They check the boiling point. They can also check the melting point. So there is always a list of the pure substances. So in that table, they have all the melting point and the freezing point and the boiling point, etc., of different pure substances. Okay, then they are going to compare. Is it correct? If it's not exactly that temperature, the substance is not pure, then they will reject. Okay, send back to the original country. All right, cannot enter Singapore, something like that. Okay, so take note, pure substances must have fixed melting boiling point. Impure substance will not have fixed melting boiling point. Okay, so we call the pure substances either elements or compounds. All right, and then for mixtures, we call them impure substances. I give you one example. Okay, so water is compound. Water has a formula H2O. All right, so element, maybe I can talk about oxygen. Oxygen gas, it is an element. It will have a fixed melting boiling point. Okay, water also fixed melting boiling point. Yeah. So mixture, for example, I have salt added into water. So this is called salt solution. It's a mixture of salt plus water. Okay, so this is a mixture of salt and water together. It's called salt solution. When I try to test, let's say, the boiling point of salt solution, I see that it starts boiling. Okay, so see all the bubbling coming out, maybe starting at 101 degrees Celsius. It can go towards a range, So as I keep boiling it, the temperature seems to be increasing. Okay, and then it will probably stop at maybe 104, 105 degrees Celsius. So the boiling starts at 101. Okay, you see a lot of bubbling taking place, but it continues bubbling and the temperature is still rising up to a certain point. So we can say mixtures, right, boil over a range of temperature. Now, if you are asking me whether I need to copy all this, don't copy. I will give you this, exactly the one that I am writing on now. Okay, later on at the end of the lesson, I will send it to you as a PDF. Okay, so you have the notes for the lesson today. Okay, so don't copy. So that is mixture. Now we are only going to focus on elements today, okay, for today's lesson. All matter is made of elements. Even you and me, we are made of elements. There are so many elements inside us. Okay, so in order for you to learn complicated stuff, we have to start from the basic. So we learn the most basic building blocks of all living and non-living things, which is elements. And elements, surprisingly, maybe not so surprising we actually know what they are, okay? Because they are all found in the periodic table, which is why I told Evan, right? Evan came in at 7:33. Then I told him to quickly go and get the textbook because we need the periodic table. And he did, okay? So the rest of you, Heidi, if you have your periodic table with you, that will be useful. Okay, Jared, you have your periodic table with you, the science textbook? Okay, if you have, that will be good. If you don't have, later on during break time, can you quickly go and grab it? Okay. Of course, I will be showing, I'll be showing a lot of periodic table throughout the lesson. Okay, now, so elements and their uses. These are just a few examples. Okay, there are a lot of elements in the periodic table. You need to know some common ones. Okay, for example, aluminium. We talked about aluminium before. Okay, the density is lower. Remember, we talked about density also. Yeah, when we refer to density, aluminium seems to be very light. Yeah, so it's used to make aircraft and also drink cans. Why use aluminum to make aircraft? Because it's so light, okay? The aircraft body wouldn't be too heavy. You need the aircraft to fly in the air, and you need to carry people inside the aircraft. So can you imagine if the aircraft is too heavy, it might be not able to fly properly and it might just, drop easily. So if the aircraft body is light enough, it can actually move safely. It can travel to the destination easily and don't use up so much of the fuel. Drink cans as well. Can you imagine if you buy a can of Coke and it's going to weigh 1 kg? Do you want to carry your can of Coke around? 1 kg of canned Coke is too heavy for you to carry, right? Okay, so we try to make it as light as possible. Copper, very useful metal. It is the one that is most distinct in a way because it has a certain color to it. Now, copper is reddish brown. Many times you will also see the word pink brown. Okay, so this is the color of copper. It's used to make wire and water pipes. Remember some of these uses because you'll be tested in your WA or in your year-end exam. Fluorine is a pale yellow-green gas. It's called yellow-green. Okay, it is pale. Even if you miss the word pale, doesn't matter. Very important is you must know it's yellow-green. So if you look at the color here, although you see it like it's very yellow. Okay, if you compare with fluorine, which is another gas, then you understand why this is known as yellow-green. There is a tinge of green color in this round bottom flask. Okay, if you can see. So it's a yellow-green gas. It's used as disinfectant, all right, or purification agent. Now, if you were to ask me where can we find chlorine, check the swimming pool. You know, the swimming pool has a very distinct smell, right? Yeah, that is the smell of chlorine. You know, bleach solution. Bleach also carries chlorine. Okay, so if you want to know, yeah, it's actually found in swimming pool because they need to disinfect the pool's water, right? They can't change the entire water all the time. It takes a long time to fill up the whole swimming pool and it takes a lot of water. So what they do is they will put chlorine in to kill all the harmful bacteria, to disinfect the water. All right, so they will add in chlorine instead of changing the entire swimming pool of water. Right. Carbon. Now, carbon, very interesting. Not too sure whether you have already learned. I think we have gone through these before. Okay. Carbon is found inside iron to make steel. Okay, it is found inside your pencil lead. The pencil lead that you write with is actually made of carbon. We call it graphite. Okay, carbon is also found inside coal, coal, charcoal as well. Okay, then it is found inside diamond. So diamond is so expensive. It is actually made up of carbon element. Coal is so cheap, charcoal and coal, pencil lead is so cheap, right? But they are all made of carbon. So the way carbon is being bonded together, okay, the way its structure is being formed will determine its value. So if you are to research on diamond, you will understand a bit more. How come it's so expensive when it's just made of the element carbon? All right. So elements, okay. Proper definition is in the pink box here, or if you can see the pink rectangle here. Okay, an element is a substance that cannot be broken down into simpler substances by chemical methods. It is already the very basic building blocks of all things. You cannot break it down further. Yeah, so an example here, okay? So we have the example over here, like sodium chloride. This is actually a compound.